Record. Okay, AP Calculus lesson 4-4. Today's date is Thursday, November 5th, 11/5/2020. Our objective today is to do what, Andrea? Yeah, you thought that you were done with it in Unit 2. No, it comes back over and over and over again. Teflon, what is mean value theorem?
F prime of C I forgot if it was F of A or F of B first. But
Technically, both of them work as long as they're the same thing. So if you do F of A minus F of B all over A minus B, that actually works. It's not the definition that you have for your speed sheet, but it still works as long as they're the same direction. Typically, we do the second point first, and I'm getting like some crazy bad lag. F of B minus
F of A.
A all over.
I forgot this part.
It's going to be just these inside pieces.
Okay, so F of B
Just B
minus A.
You want to say, yeah, nice. And again, what this is really saying, if I were writing this out in words, is that the slope of the tangent, so I'll write out the slope of the tangent is equal to the slope of the secant. And why am I getting such bad lag? This is weird. Slope of the secant. And it's the secant from where to where? From A to B. From A to B, and I guess the slope of the tangent at C. All right, so there's going to be a lot of algebra in this lesson, but let me talk about the picture representation of what's happening right now. So let's go ahead and find the slope of the secant line from A to B. And this is where you kind of just get to sit back and you'll take notes at the very end. So if I have the secant line, let's go ahead and do that in red. From A to B, there's that secant line. I guess I could extend that line out farther and say, okay, the secant line is a line. It's not a line segment. It goes forever and ever. And then you just have to move that. Where do I drag this line until it's only tangent to one spot? And then I drag it to right there. And you can say that the point of tangency is right here. So today what we're trying to find is we're trying to find the x value of this point of tangency. And then the answer obviously is at that x coordinate right here. If I drop a line to this, maybe I make that line orange or something to kind of distinguish it. This x coordinate is the c value that I was searching for. We're in the hunt for that c. All right, now you can take notes on that. You can say, okay, we're trying to find the tangent line that is the same slope as the secant line. Maybe just so I have it better for my notes, I can maybe copy and paste this secant line down here. But essentially what we did was we took that secant line and we moved it in this direction until it was only touching the curve once. You move it all around. I mean, graphically, you can move it down, you can move it right, you can move it up, down, left, right, any direction, as long as it touches the curve once. And in terms of this graphical representation, you're probably noticing, well, depending on the type of curve that you have, you can have a bunch of different answers. Like think of a sine wave, right? If I had a sine wave that was maybe modulating and was going in a linear direction, is going up, there's probably quite a few points of tangency. Like there would probably be one there, one there, one there. And we do have to be careful as teachers and creators of AP tests to make sure that we give you only a curve that has one. Or if it has multiple, we'll give you a range and say, hey, look between here and here. Don't look anywhere else. And Andrea, can you not put your feet on the desk? Thanks. It eventually bends those drawers slowly over time. Maybe not this year, maybe not next year, but in 10 years, it will eventually be not so good. All right, so any questions on our graphical representation of what's going on? All right, moving on to example number 1. If c is the number that satisfies the conditions of the mean value theorem for that function x cubed minus x squared, and it tells me the range to look at, only look between 0 and 1. What is the value of c? So it's the same type of question. Hey, look between a and b, only look between here and here. Find the secant line first, and you'll get the slope. Where is that slope on this this curve, and then you'll move that around until you find the x-coordinate. Once you get the x-coordinate, we're done. So again, start with your secant line. And maybe we should just start with the definition of mean value theorem, right? Mean value theorem, I'll do it up here in the top. Let's say, Fiona, go ahead and repeat mean value theorem. Get some practice. There's f of b minus f of a all over b minus a. And did you say f prime of c or f of c? Yeah, okay, f prime, good. Because it should be the derivative over there. So we need to find all of these values, f of b, f of a. What are those? Oh, why did I write f of c? Weirdly. We need to find all of those values. So we have to go ahead and choose an a and a b. And it tells us the interval over here. So let's just go ahead and say a is the first point, b is the second point. I think that's the most logical way to do it. Although if you switch them around, you will still get the same answer. If you call 1a and 0b, same thing. Okay, so I'm already filling in my equation over here. The denominator is now 1 minus 0. But f of b and f of a, I don't know those. I don't have a graph to figure out what those are, so I need to figure them out. So it is, yeah. So f of b is f of 1 because we're plugging in 1, which means I'm plugging in 1 into each of these x's. So it's really going to be 1 to the power of 3 minus 1 to the power of 2. And what is that, Andrea? What is 1 cubed minus 1 squared? Yeah, 0. So we can come back up here and fill in f of b was 0. Again, I can rewrite this again to the right if you need it. That was f of b that we just found. I stated that over here on the left-hand side, and there's a series of equal to signs. But I'll go ahead and rewrite it just in case you need to see it there. What about f of a? We'll give that to Teflon. What do I do for f of a?
Would that be f of 0?
It is indeed f of 0, which means I'm plugging in 0 into my equation over here. So 0 cubed minus 0 squared, which Teflon is?
0.
0. And I chose one of the most boring possible examples, but it's nice and easy to get your head wrapped around how this problem works. So that is, again, f of a. I'll rewrite it. I don't need to. That's our f of a. So we can come back up here and say 0 minus 0 for our numerator. And lo and behold, our secant line's slope is 0 over 1 or just 0. That's the slope that we're trying to get. How? Well, we need to find f prime of c, which means I'm taking the derivative of f, because that's what it means, f prime, right? Take the derivative, and instead of writing x's here, we're going to write c's, because it says change or substitute c in for the place of each of these x's. So first we need to take the derivative. We'll give that back to Fiona. 3c squared minus 2c. Nice, you did the derivative, or you took the derivative and you also substituted in the c at the same time. That's perfect. Saves me a step. And again, that is the left-hand side. The left-hand side is f prime of c. The right-hand side is f of b minus f of a all over b minus a. So maybe I can label, this was the, right here, that was the left. Oh wait, maybe I should say, this piece right here, this is the left. All of this was the left. And this piece right here that we were working on, oh wait, why did I say left? Sorry about that. That's the right. My rights and lefts are hard. That was the right piece. And then this f prime of c, that is the left piece. I'm going to set my left equal to my right. I'm basically substituting back into my original mean value theorem. F prime of c, as Fiona told us, is 3c squared minus 2c. So I'm running out of room, so I'm going to hopefully be able to solve it in this tiny little corner down here. So the left piece is 3c squared minus 2c. I'm going to set that equal to the right piece, 0. And then I'm going to solve. I'm literally just figuring out what is the left piece and right piece of mean value theorem and then solving the equation that generates. Andrea, you're up. How do I solve 3c squared minus 2c is equal to 0? Divide by 2. Let me zoom in here. We're just trying to solve for C. What is C equal to? If you square root that entire side, you can't just square root a piece of the side, you have to do the same thing to the left and the right side of the equal to sign. So if you square it, you're gonna have to square the whole piece, and that's kind of lead us in circles. I'll give you a hint. Factor. C times 3C minus 2, and that's still set equal to 0. Use the zero product property now, Andrea. There should be two equations that come from this. What's one of the equations? And the other equation is? You did it all in your head. Perfect. And we're there now. Let me write out the steps that you did to get that. You also did 3C minus 2 is equal to 0. And then you did the math in your head and you said C is equal to 2/3. Beautiful. Nice. And those are our two answers. But there's only, because again, I told you, depending on the type of curve, you might have two answers. But they told us only look. Oh, I need to change that problem. Dang it. Between 0 and 2/3. So there actually are two answers. I need to change this for next year. Okay, let's go ahead and pretend it was a less than sign there instead of a greater than sign. That means that that 0 would not be included because it's not in the correct domain. So then our answer would only be C is equal to 2/3. You always have to check your range because, or your domain. You should only have one answer if the AP graders and teachers were making the problems correctly. Obviously, I'm not, so sorry. I made a mistake. Let's go to example number 2. Kind of same question. What is a C that satisfies mean value theorem for that equation? And my bounds here are between 0 and 6. This is our last question. We're done. We don't have a backside. I want to see each of you do it on your own. Let me go ahead and pause the recording. Okay, so this problem, let's first find, well, I guess we should rewrite our mean value theorem. So who has not done it so far? Teflon, have you read out mean value theorem already? You have? Andrea, have you done it? Andrea, go for it. A all over B minus A. And whenever I ask you for the slope of a secant line, that's the same definition as just that right side. That was a speed sheet question that I forgot to put on our unit 1. All right, so we need to find a few things. Let's work on finding f of b. I'll do it up here. F of b, let's go ahead and just kind of randomly here say a is 0, b is 6. I know my b's and 6's kind of look the same. F of b, therefore, is going to be f of 6. We're plugging in 6 over here. 1/2 of 6 quantity squared plus that 6. Fiona, what'd you get for this? 24. Teflon, Andrea, agree? Thumbs up, not head. Good. Okay, let's do f of a. F of a is going to be equal to f of 0, and that means I'm doing 1/2 of 0 squared plus 0. And Teflon, what'd you get for all of this? 0 squared times 1/2 plus 0 is 0. Yep. All right, so we can fill in our equation almost. I still need to find what's f prime of c. So let's come do that in a different color. F prime of c. Andrea, help us out. Take the derivative, plug in c. C plus 1, exactly, yeah, because the 2 comes down in front, 2 times 1/2, cancel each other out, and you're just left with x, which is substitute out for a c, and the derivative of x is just 1. So c plus 1 is our derivative, and then we can fill in everything over here. So I have c plus 1 on the left-hand side. On the right-hand side, I have f of b, which is 24, f of a, which is 0, all over b, which we know up here is 6, minus a, which is 0. 24 divided by 6 is 4. So our new equation, I know I ran out of room, is c plus 1 is equal to 4. Subtract 1 on both sides, and c is equal to 3. All right, Teflon, did you already find your mistake?
Yeah, I didn't set it equal to 4.
Okay. Cool. That's it for the lesson. Give me a fist of 5 on our objective today. How well can you use the mean value theorem to solve problems? 4, 4, and 5. All right, thanks. That's the end of the lesson then.